Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Nuclei. In the previous part, we had solved till the question number 20. So in this second part of this video on Nuclei, we shall start from question number 21 onwards. So in any steps, if you have any doubts, write that in the comment section. We shall clarify them in the subsequent videos. And in any other chapter of physics, if you have more difficulty, then also mention the name of that chapter in the comments so that we can give more clarity on it, more and more questions on that chapter. Also, some important homework questions on the previous year KCET exam will be uploaded in the Sapience application. So please install our Sapience Education application. The link has been provided in the description. So here in question number 21, it is told nucleus X at A emits an alpha particle with velocity v. The equal speed of the outer nucleus is. So it emits an alpha particle, means with He24, means the outer nucleus is supposed that will have atomic number Z-2 and mass number 2. So the recoil speed of the nucleus is how much? So the speed of the alpha particle is v. Then the recoil speed of this daughter nucleus is y. Suppose its speed is v1. So here we can apply the conservation of linear momentum. So according to the principle of conservation of linear momentum, m1v1 plus m2v2, that is equal to initial momentum of the system, that is. So therefore m1 mass of y, mass of the daughter nucleus, that is a minus 4 times q is the atomic mass in it. Then I can write a minus 4 into 1, that is equal to m2. M2 is the mass of the alpha particle, 4 m, so that is minus 4 into v2, that is v. Therefore v1 is minus 4v by minus 4. So therefore the recoil velocity is 4v by a minus 4. So option B is the correct answer. In question number 22, it is told a radioactive substance emits 100 beta particles in the first 2 seconds and 50 beta particles in the next 2 seconds. The mean life of the sample. So it emits 100 beta particles. First 2 seconds, 50 beta particles in the next 2. It means that the half-life of the radioactive substance is 2 seconds. So now the half-life that is given as ln2 by lambda. The mean life is given as 1 by lambda. So therefore ln2 by lambda, that is equal to 2 seconds. So 1 by lambda will be equal to 2 by ln2. 2 by ln2 means 2 by 0.693. So option C is the correct answer. The mean life of the sample is 2 by 0.6. Question number 23 is to which one of the following is not correct? In forward biased condition, diode conducts. The forward biased condition, the diode conducts If the packing fraction is negative, the element is stable. Binding energy is the energy equivalent to mass effect. Forward bias condition. The diode conducts. Forward bias condition. The diode conducts. If the packing fraction is negative, the element is stable. Binding energy is the energy equivalent to mass effect. Radioactive element can undergo spontaneous fission. No, this is not correct. So 23 option D is the correct answer, since it is the wrong statement. Then question number 24, it is told A and B are the two radioactive elements. The mixture of these elements show a total activity of 1200 disintegrations per minute. The half-life of A is 1 day and that of B is 2 days. What will be the total activity after 4 days? Given the initial number of atoms of A and B are equal. So the activity is given as lambda times n, which is equal to lambda n naught e power minus lambda t. And lambda is the radioactive decay constant. Mixture of these elements total activity. Okay, so the initial number of atoms of A and B are equal. So I can say the number of atoms of A is also n naught initially, or B also it is n naught initially. Therefore, for half-life of A, that is 1 day. Therefore, it's equal to ln2 by lambda 1. Suppose, and the half-life for B, that is equal to 2 days. But lambda 1 and lambda 2 are the radioactive decay constants for the radioactive elements A and B respectively. So therefore, the total activity after 4 days, that will be A1 plus A2. The mixture of these elements show a total activity of this. That means that the initial activity, that is A naught. Initial activity will be A1 plus A1 naught plus A2 naught. That is lambda 1 naught plus lambda 2 n naught. That is given as 1200 disintegrations per minute. So therefore I can say lambda 1 plus lambda 2, that is equal to 1200 by n naught disintegrations. This is per minute. So to find A1 plus A2, that is equal to lambda 1 n1 plus lambda 2 is equal to lambda 1 n naught e power minus lambda 1 t plus lambda 2 n naught, that will be equal to n naught into lambda 1 e power minus lambda 1 t lambda 2 e power minus lambda 2. So 4 days. So t is equal to, here t is equal to 4 days. Lambda 1, that is equal to ln2 by 1 day inverse, that's per day, and lambda 2 is ln2 by 2 per day. therefore A1 plus A2 will be equal to naught to lambda 1 e power minus 1 by 1 into t is 4 days plus lambda 2 into e power minus 2 by 2 into 4 days. This will be n naught into lambda 1 minus 4 ln 2 means e power ln 2 power minus 1 by 2 power 4 plus lambda 2 power by 4. This is not into lambda 1 by 3 plus lambda 2 by 4. Here this is equal to n naught by 16 into lambda 1 plus 4 lambda 2. That is equal to n naught by 16 into this is ln 2 by 1 plus this is ln 2 by 2. 4 into ln 2 by 2. N naught 16 2 ln 2 plus ln 2, that is 3 ln 2, that is ln 2 power 3, so ln 8, that is 3 ln 2. And here so that n naught into lambda 1 plus lambda 2 1200 naught into ln 2 by 1 plus ln 2 by 2 is equal to 1200. It means that n naught by 2 into 2 ln 2 plus ln 3 ln 2 is equal to 1200. Therefore this I can write, this will be 1 by 8 n naught into 3 ln 2 by 2. This 1 by 8 into 1200. This will be 4 to 8, 4 to 12, 2, 150 integrations per minute. So option D is the question number 25 is the binding energy per nucleon of deuteron. Binding energy per nucleon for deuteron for H12 is 1.1 mega electron volt, and for helium 824 is 7 mega electron volt. If two deuteron atoms fuse to form a single helium atom, then the energy released is so two deuteron atoms to produce single helium atom, then the energy released, that is how much that will. Therefore here the energy is, that is supposed to. So we know that the binding energy of helium, that will be equal to the 4 into it is 2 into mass of neutron plus 2 into mass of proton minus the mass of helium is into c square. Binding energy of helium, that will be 7 mega electron volt into the number of nucleons, that is 4, that is 28 mega electron volt. And binding energy for deuteron, is equal to mass of electron plus mass of proton minus the mass of deuteron to c square. That is equal to mass of neutron, that is equal to the binding energy per nucleon 1.1 mega electron volt into the number of nucleons is 2.2 mega electron volt. So therefore, the energy that will be released, that is equal to the mass of deuteron, twice of that, minus mass of helium into c square. That is equal to the binding energy of helium minus twice of the binding energy of deuteron. So that we have to find. So 28 mega electron volt minus 4.4 mega electron, that is equal to 23.6 mega. Option C is the correct answer. Then we told the relation between half-life and decay constant. So the half-life is equal to ln 2 by. It means that lambda into t, that is equal to log base e t. Option A is the. A radioactive decay can form an isotope of the original nucleus with the emission of particles. Radioactive decay can form an isotope of the original nucleus. Radioactive decay isotope of the nucleus. So a radioactive decay can form an isotope of the original nucleus. Is that suppose XZA can produce XZ B, suppose let's say this is A1. It means it can 1 alpha and 2 beta. It means the net charge should be 1 alpha means He24 and 2 beta means E minus 1. So that can happen. 2 alpha, 1 beta, no. 1 alpha, 4 beta. So only option A. Option A is the correct answer. So then it will form, suppose this it has mass number A. So here it means that if this mass number is A, then it will form X. Option A is the correct answer. Question number 28 is told the half-life of a radioactive substance is 20 minutes. The time taken between 50% decay and 87.5% decay of the substance will be. 50% decay has been done, so it means it will go from N0 to N0 by 2, and 87.5% decay means it means that 12.5% is remaining, so 12.5 by 100, that is equal to 25, 5 is 125, and 25 4 is 100, 1 by 8 part, N0 by 8. This, so N0 by 2 will go to N0 by 8 in how much time? That we have to find. So N0 will go to N0 by 2 in 1 half life. N0 by 2 will go to N0 by 4 in 1 half life. N0 by 4 will go to N0 by 8 in another half life. Means that N0 by 2 will go to N0 by 8 in 2 half life. So the half life is given as 20 minutes. So 2 half lives is 40 minutes. Answer is question number 29. A nucleus at rest, nucleus is kept at rest, and it splits into two nuclear parts. Having radii in the ratio 1:2. If its ratio is r, its ratio is 2r. Its radius is 2r. Then their velocities are in the. It will have velocity, suppose v1 and this is v2. So therefore, we have to find v1 is to v2. So now, we know that nuclear density is always constant. Nuclear density is constant. So therefore, their masses is equal to density into volume. So mass of a nucleus, that is proportional to the volume only. Means mass and volume, if I consider it as a sphere, so then volume is given as 4 by 3 pi r cube. So their mass of the nucleus is proportional to r cube. Now therefore here we can say that we apply the conservation of linear momentum, apply the conservation of momentum of those two parts. Then we can say that m1, its mass is suppose m1, its mass is suppose, and I can say m1 v1 plus m2 v2, that is 0. Since the initially the place was at rest. Therefore I can say that m1, which is density into 4 by 3 pi r cube, plus that is m2, which is rho into 4 by 3 pi 2 r into v2, that is equal to 0. So 4 by 3 pi, this will cancel out, and I will have this is r cube v1 is equal to minus 8 r cube v2. R cube will cancel, so v1 by v2, that is equal to minus 8 by 1. Therefore if we want to find the ratio of their magnitude only, then that is 8:1. C is the correct one. Then it is told a radioactive sample of half-life 10 days contains 1000x nuclei. 1000x nuclei, half-life is 10 days. Number of original nuclei present after 5 days. So 5 days, it means half of half-life. So therefore we know that n is equal to n naught, the number of nuclei present in time t, that is equal to n naught into e power minus lambda t. So here is ln2 by lambda, that is equal to 10 days. So after 5 days it is off, so this is n naught 1000x e power minus lambda into t, that is 5 days, that would be equal to ln2 by 2 lambda. That says 1000x into e power ln 2 power minus half. So that is 1 by 2 power half. That means it is 1000x divided by root 2. So this I can write it as 500 into 2, so 500 into root 2. Root 2 is 1.414. 1.4 into 500. 5 fourths of 7. So that is 707x. And A is the correct answer. Then in question number 31, it's told that an element x decays to element z by two-step process. X decays into y plus y decays into z plus 2 electron. Then so here if it is ZA, then y is z minus 2, mass number is y, electron means E minus 1. Z Is that X and Z are isotopes. And Z are isotopes. D is the correct answer. A nucleus of mass 20U. Nucleus, its mass is 20U. It emits a gamma photon of energy 6 mega electron volt. If the emission assumed to occur when nucleus is free and at rest, the emission assumed to occur when nucleus is free and at rest, then the nucleus will have kinetic energy nearest to if the emission assumed to occur when nucleus is free is at rest. Then the nucleus will have kinetic energy nearest to. So it will have some kinetic energy also. Here we have to apply the momentum conservation. Yeah. According to the principle of conservation of momentum, according to the principle of conservation of linear momentum, say that one d plus the momentum of the gamma photon, that is E by C is equal to 0, since it was initially at rest. As the emission occurred from this, which was therefore now kinetic energy, that is equal to T square by 2m. mv, that is P, that is equal to E by C, minus of E by C. P is equal to minus of E by C. Now, therefore kinetic energy will be equal to energy of the gamma photon divided by C whole square divided by 2. This is the mass. Yes. For the kinetic energy, that will be kinetic energy of nucleus, that will be equal to energy of the photon, 6 mega electron volt. So 6 into 10 power 6 electron volt is 1.6 into 10 power minus 20 whole square divided by C square. So 3 into 10 power 8 whole square to 1 by 2. 2 into mass is 20. So 1 U is 1.6 into 10 power minus kg. So this we have to solve. This is equal to, it is a 6. It is 3.2 into 10 power. This will be minus 2 minus 21 whole square into 1 by 40 into 1.6 into 10 power minus 27. So the kinetic energy will be equal to 3.2 into 3.2 into 10 power minus 21 to 10 power minus 21 divided by into 1.6 10 power minus 7. 1.6 2 2 10 1.6 into 10 power, this is minus 42 or minus 26 plus 1.6 into 10 power minus 6 much joule. 3 second, right? This is 10 power 3 into 1.6 into 4 is 10 power 3 electron volt. This is 1 kilo electron. Option B is the correct answer. And question number 3 it is called the particles emitted in the decay of uranium 232, uranium 238, uranium 234. The particles emitted, that will be 1 alpha particle, 2 beta particles. Since the charge is constant, number of protons is constant. 1 alpha particle means He24, 2 beta particles means 2 E minus 1 0. This is option D is the correct. In question number 34 it is told, in a nuclear reactor the function of the moderator to decrease speed of neutrons is the speed of neutrons. Question number 35 it is told, the mass defect of helium He24 is 0. The delta M for this is 0.03 U. Binding energy per nucleon of helium in megaelectron. The binding energy per nucleon for helium, that will be, the binding energy will be delta M into C square divided by number of nucleons is 4. That will come, delta M is 0.03 and 1 U into C square. 1 U I can write, that is 931 megaelectron volt per C square. 0.3 U 1 U into C square, that I can write 931 megaelectron volt divided by 4. This will be equal to 6.98 electron volts. Option B is the correct answer. Option B is the correct answer. The energy equivalent to a substance of mass 1 gram is energy equivalent to a substance of 1 kmc. 1 gram means 10 power minus 3 kg. And that into C square, so it is 3 into 10 power 8 whole square. So that much, 9 into 10 power 3, that is 9 10 power. Option B is the correct answer. Question number 37 is told, half-life of tritium, half-life of tritium 12.5 years. What mass of tritium, initial mass 60 milligram, will remain decayed after 50 years? 64 milligram is the initial mass. You can call it as m naught. And how much is the mass m that will remain undecayed? That will be equal to the number of atoms of tritium, the number of nuclei of tritium into the atomic mass. This 3u. 3. And so you can find the initial number of nuclei, that is m naught by 3u. I can say the atomic mass of tritium, it is suppose capital M. Atomic mass is suppose capital M. So m naught is 64 milligram, means 10 power gram by m. And m is the atomic mass of tritium in grams. So therefore we know that m will be equal to n naught e power minus lambda t. After 50 years, that will be e power minus lambda. So this is ln2 by lambda minus lambda into t. T is 50 years. This I can write ln2 into e power minus lambda is ln2 by t half. So ln2 by 12.5 into 50. That is 48. 4, so minus 4 ln2. So ln2 in, not into e power ln2 power minus 4. So that is ln 1 by 2 power 4. So this will be n naught by 2 power 4. N naught by 16. N is equal to n naught by 16. The mass that is present n naught by 16 into m. 1 by 16 into n naught, that is 64 into 10 power minus 3 divided by m into m. 64 by 64, so that is 4 milligram. 4 milligram will remain decayed. Option D is the correct answer. Okay, question number 38. Question number 38 shows that which one of the following nuclei has shorter mean life? dn by dt. dn by dt, that is equal to lambda m. At time t equal to 0, all are having same value of lambda equal to 0. Lambda 1, lambda a and a, that is equal to lambda b and b. And lambda 1 n1, that is equal to lambda 2 n2 naught. Plus, so that is equal to lambda 3 into n3 naught, where lambda 1, lambda 2, lambda 3 are the radioactive decay constants for A, B, and C. N1 naught, N2 naught, N3 naught are the initial number of nuclei for the radioactive substances A, B, and C. Therefore, at time t is equal to mean life, n1 will be equal to n1 naught by n2 will be equal to n2 naught by n3 will be equal to n3 naught. So So the time will be same. Graph is like this. So at time t means suppose this mean life is not by e. Not mean life. Lambda 1 n naught n1 naught by e. By e also will be the same. Lambda naught n1 naught by e, that is equal to lambda naught 1 and 2 naught by e. Lambda therefore their activity, so it is the graph of actually activity versus time. The activity will also change to activity by e, since the initial activity by e. So this will be the graph, so it means that this is activity, this will be a naught, so a naught by e. So the mean life of a is the least, mean life of b is medium, and the mean life of c is the highest. Which of the following has shorter mean lives? That is for a. Option b is the correct answer. Question number 39. The end product of the decay of thorium 90-32 is 8 cb82-208. Then the number of alpha and beta particles emitted are respectively. So let's suppose n number of alpha particles are emitted. It means n He24 are emitted, and suppose m number of beta particles are emitted. M number of beta particles means e minus 1 0 are emitted. Therefore, I can say that 82 plus 2n minus m, 82 plus 2n minus m, that is equal to 90, and 208 plus 4n plus m into 0, that is equal to 232. Therefore, I can say 4n, that is equal to 232 minus 208. Therefore, 4n, that will be equal to 24, is equal to 6. Therefore, m will be equal to 82 plus 2 into 6 minus 20. It's 2 plus 12, 96, 94 minus 90, that is equal to 4. So it means that 6 alpha particles, 4 beta particles are emitted. Option D is the correct. Then question number 40, it is true. A radioactive element has half-life of 15 years. So the half-life is 15 years, is equal to ln2 by lambda. Then what is the fraction that will decay in 30 years? That means that in 2 half-lives, 30 years means 2 half-lives. 2 half-lives means in 30 years, so n is equal to the number of nuclei that will remain undecayed. Number of nuclei that will remain undecayed at time t, that is given as n is equal to n naught e power minus lambda t. So is equal to n naught e power minus lambda, that is ln2 by 15 years into 30 years. So that is equal to n naught into e power ln2 power minus 2. So that is n naught by 4. So n naught by 4 will remain. So therefore 3 n naught by 4 has decayed. We have not has decayed in 30 years. So therefore, the fraction that has decayed in 30 years, fraction that has decayed in 3 by 4, 0.75. So A is the correct answer. And in question number 41, it is told two protons are there. Two protons means their mass is 1. They are kept at a separation of 10 nanometer. 10 nanometer. Let Fn and Fe be the nuclear force and the electromagnetic force between them. 10 nanometer, it means it is more than the nuclear range. It is more than the nuclear range. So when the two protons are within the nuclear range, means within 1 Fermi, within the range of 1 Fermi, then only we can say that the nuclear force is much higher than the electromagnetic force. But here the separation is 10 nanometer, which is much greater than the nuclear range, which is 1 Fermi. Therefore, here the nuclear force will not act. Here the electromagnetic force will be much greater than the nuclear force. Option D is the correct answer. In question number 42, it is told during beta minus decay, what happens? A neutron will decay into a proton and an electron and an anti-neutrino. So here a neutron in the nucleus will decay. Proton in the nucleus decays. Okay. A neutron in the nucleus will decay, emitting an electron. Option A is the correct answer. Question number 43 is told which graph in the following diagram correctly represents the potential energy of a pair of nucleons as a function of their separation. So there the potential energy of the nucleons will be of the order of mega electron volt. The potential energy of the nucleons is of the order of mega electron volt. Since we know that 1 U into C square, that is equal to 931 mega electron volt. It means the binding energy of every nucleus is of the order of mega electron volt, 1 mega electron. So the potential energy of the nucleons will be also of the order of mega electron, 1 mega electron. So therefore, and when the separation is much higher, then the potential energy will tend to 0, and there will be a minimum of potential energy where the separation is at equilibrium, which is called as the equilibrium separation of the two nucleons. And then gradually energy will increase when it comes close. So it means when the two nucleons are very close, then there will be repulsion, and when they are very far apart, then there will be attraction. And when there is equilibrium separation, then the net force in between them will be 0. So option D is the correct one. Number 44, it is told in a nuclear reactor, heavy nuclei is not used as moderators because heavy nuclei is not used as moderators because they will break up. Elastic collision of neutrons with heavy nuclei will not slow them. The net weight of the reactor would be high. Substance with heavy nuclei do not substance with heavy nuclei do not occur in liquid or gaseous state at room temperature. So the correct answer is option D. It means the elastic collision of neutrons with heavy nuclei will not slow them when the substance with which it gets with which the neutrons is getting which it is undergoing collision, if that substance is heavy, so then its speed after collision will not decrease appreciably. So it means that heavy nuclei is not used as moderators in the fusion reactors, the nuclear fusion reactor. Option B is the correct. Then in question number 45, it is told that the binding energy of nitrogen gas N714 given by the mass is N714, that is 14.00307 U. So the binding energy that will be equal to 7 into the mass of neutrons plus 7 into mass of protons. Since why? The nucleus of nitrogen contains 7 protons and 7 neutrons. 7 into mass of neutron plus 7 into mass of proton minus mass of nitrogen into c square. And we know that 1 mu into c square is 931 mega electron volt. This will be 7 into mass of neutron, 7 into mass of neutron, that is 1.0086. Mass of neutron, I can say that is 1.00866 U, and mass of proton is 1.00728 U. This will be 7 into mass of proton plus mass of neutron minus mass of nitrogen into c square. This I can write 7 into 1.00728 plus 1.0086 minus 14.007, that into c square. So this much into 1 u, actually 1 u into c square. This I can write 7 into 1.0078 plus 1.00866. So if we add them, then we will get this 14, 9, 15, 0, 2. This is 7 into 2.01594 minus 14.00307. That into 1 u into c square is into 931 mega electron volt. This will be equal to 7 into this. If we solve it, we will get approximately 0.10851 by 1 into 931 electron volt, which will be approximately equal to 101.023 mega electron volt. which is approximately 101, so it is approximately 104 point, means option B is the closest, so option B is the correct answer since it is closest one, since it is closest to 101. Question number 46, it is told a nuclear reactor delivers a power of 10 power 9 watt. The amount of fuel consumed by the reactor in 1 hour is, so 10 power 9 watt is the power delivered. The amount of fuel that is consumed by the reactor 1 hour. So we know that power is given as energy by time. So the energy that is equal to mc square by time. So we have to find out the m, how much mass the fuel that is consumed in 1 hour, means when time is 1 hour. 1 hour, it is 3600 seconds. So therefore the power that is 10 power 9 watt, that is equal to mc square. M is, we have to find, E is 3 into 10 power 8 whole square divided by 3600 seconds. M will be equal to 3.6 into 10 power 3 into 10 power 9 divided by is 9 into 10 power, where is 16, 4 9s are 36, so that is 0.4 into this 10 power 12 minus 16 is much kg, is equal to 0.4 into 10 power minus 4 kg, say 4 into 10 power minus 5 kg, is equal to 10 power minus 3 kg is equal to 1 gram. So therefore it is 0.04 to 10 power minus 3, 0.04 gram. Option B is the correct answer. 0.04 gram of fuel consumed in 1 hour. So hope all of you have understood the solutions of all these 46 questions. So any doubts if you have, then write us in comments. And please install our Sapience application, where we shall upload some important homework questions on KCET exam, which shall be helpful for you. Thank you everyone.